Dear students, the next topic we are going to see in your module 1 is beam. So all of you know about beam. So you have seen your classroom and in your house and any uh, residential, industrial, commercial buildings, reinforced concrete structure, wherever the reinforced RCC building is there, we can see the beam. So generally, we we can call beam as a horizontal member because of the position of the member. We can say beam is a horizontal member. Also we can say beam is a flexural member. That's depends on the uh, failure or load carrying capacity of the flexural failure will occur in the beam. That's why beam is always called as flexural member. So, and also usually we will calculate the flexural strength of beam in the reinforced concrete beams. So that's why you can call it as beam is a flexural member. But generally beam is a horizontal member. So in your engineering mechanics, you have already studied about types of support, what is meant by action, what is meant by reaction, types of loads, and how to calculate the support reaction. Up to this point, you have studied in your engineering mechanics. Here we are going to study the next level, that is in continuation with your support reaction. We are going to study what is meant by shear force, what is meant by bending moment, how to calculate shear force and bending moment, and also very importantly how to draw the shear force diagram and bending moment diagram. So here you can see the two pictures. One is types of support and another one is types of beams and load. So types of beams, it depends on the types of support. Based on support only we can classify the beams into different category. So as already you have studied in engineering mechanics, there are three types of supports are there. One is roller support, another one is pinned or hinged support, the third one is fixed support. So, and also you may know about what is meant by action and what is meant by reaction. The action is the external force acting on the beam. The reaction is the support. Beam is supported in 2 points or 2 or 3 more points. Whatever the support may be, the support will give the resistive force or resistance to the external force. That is called reaction. The reaction given by the support is called support reaction. So action is external force, reaction is given by the support. So for the equilibrium condition, both should be equal. If the external force and internal reactions are equal, then there will not be any collapse or damage. If the external force is increasing, the internal reaction is decreasing, then that leads to collapse and failure of the structural member, right? So roller support, hinged support, and fixed support. There are three types of supports are there. And reactions, for roller support, the number of reactions is 1. For pinned or hinged support, the number of reactions is 2. And fixed support, the number of reactions are 3. So this 1, 2, 3, this, if you remember in this order, that will not be forget at any point of time, right? So roller support is 1, number of reaction. What is the nature of the reaction? That is number of reaction is 1. That reaction is vertical reaction. Why it is vertical? Since the support is having roller, if you apply any horizontal force, it will move along the direction of force. That will not give any resistance to the horizontal force. And also if you apply moment or rotation in the support, it can be easily rotated because doesn't have any fixed. So if you apply any vertical forces, it gives the resistance. It cannot be moved in the downward direction So the roller support is gives reaction to the vertical force only. That's why the number of reaction is 1. That is also a vertical reaction. If the external force is in downward direction, the reaction will be in upward direction. Right. For hinged or pinned support, the difference between roller and hinged is only one. So if you remove the roller in the roller support, that support is called pinned or hinged support. So once you remove the roller, so it will give the resistance to the horizontal force also. So the number of reaction is 2. One is horizontal, the second one is vertical. But it can be rotated. So it is not giving resistance to the rotation. That's why number of reaction is 2 for hinged or pinned support. You can clearly see in this picture. And the third one is fixed support. So all the 3 directions are fixed. So it cannot be moved horizontal, cannot be moved vertical, and cannot be rotated. And so the fixed support is giving reaction, resistance against horizontal force, vertical force, and moment or rotation. So number of reaction is 3. Hope you are all understand this concept, right? Right. Based on these supports, we can classify beams into different types: cantilever beam, simply supported beam, fixed beam, overhanging beam, continuous beam, and one more beam is there. It's propped cantilever beam. So before knowing about the different types of beams, we must know the basic thing, that is determinate beam and indeterminate beam. What is maybe determinate and indeterminate beam? So you may all know about equilibrium equations. By using the equilibrium equations only, in your engineering mechanics, you have solved the beam and find the support reaction. What are the equilibrium equation? Summation h equal to 0, summation v equal to 0, summation m equal to 0. That means sum of all the horizontal forces equal to 0. Sum of all the vertical forces in the beam is equal to 0. Sum of moments of all the forces in the beam is equal to 0. These 3 are equilibrium equations. If any beam can be analyzed by using these equilibrium equations alone, that beam is called determinate beams. If it cannot be analyzed by equilibrium equations alone, is called indeterminate beam. Simple. By using equilibrium equation, you can be able to solve the beam. Well and good. That beam is called determinate beam. If you cannot solve the beam, analyze the beam by using equilibrium equation, is called indeterminate beam. So as already I have told, different types of beam. There are 6 types of beams are there: cantilever beam, simply supported beam, overhanging beam, fixed beam, continuous beam, propped cantilever beam. Out of these 6, 3 beams are comes under determinate beam, and another 3 or comes under indeterminate beam. Cantilever beam, you can see this diagram in the previous diagram. One end is fixed, another end is free. Simply supported, one end is hinged, another end is roller. Both ends are hinged, but both ends should not be a roller support. Overhanging beam, beyond the simply supported, some portion of beams are hanging without any support, projected. Some portion of beam projected beyond the support is called overhanging beam. And the next one is fixed beam. Both ends of the beams are fixed. And continuous beam, if the beam is having more than 2 supports, maybe a 3, 4, 5, 6, whatever number. More, if the beam having more than 2 support, that beam is called continuous beam. And the last one is propped cantilever. In the cantilever beam, one end is fixed, another end is free. In the free end, you are giving some hinged or pinned support. That beam is called propped cantilever beam. And also you have already studied about types of loads, that is point load, uniformly distributed load, uniformly varying load. So here you can see what is meant by point load, what is meant by uniformly distributed, what is meant by uniformly varying load. So point load means that is acting on the particular point. Uniformly distributed means between 2 points it is distributed uniformly from first point to last point. Uniformly varying, it is looked like a triangular distributed, not uniform. It is uniformly varying from starting point to end point. Each and every point the load value is varying. So you can see the types of loads in this picture. So coming to the important topic, that is up to this you have already studied in your engineering mechanics, but this is the next level, that is shear force and bending moment. Here the ultimate aim is we want to draw the shear force diagram and bending moment diagram. To draw the shear force and bending moment diagram, we must know the shear force values in different points in the beam and bending moment values in the beams. So what is maybe shear force? It is the algebraic sum of all the vertical forces either left or right side of the section. So if you want to find the shear force in the beam, see any point or center or 2 meter from left support or 5 meter from right support, wherever. If you want to find the shear force in the particular point, you can either consider left side of the point or right side of the point. If you consider left side, the shear force in the particular point is algebraic sum of all the vertical forces in your left side of the section. And bending moment, the moment, the moment, if you heard the word moment, two things has to come in your mind. One is force, another one is distance. Moment means force into perpendicular distance. This is very, very important. The word moment, if you heard this word, means these two things should come into your mind. One is force, another one is moment, sorry, distance. So you can see algebraic sum of moments of all the forces about a point either left or right side of the section. If you want to find the moment in the particular point, you have to take the moments of all the forces in the left side or moments of all the forces in the right side about the particular point where you want to find the bending moment. So this is the basic definition for shear force and bending moment. And also you must know about what is meant by hogging bending moment, what is meant by sagging bending moment. So this is also very, very important in design point of view. Okay, you can see in this picture. So first one is hogging bending moment. So bottom of the beam feels compression and the top of the beam is tension. And the next one is sagging bending moment. Bottom experiences tension and top surface experiences compression. So based on this only, the reinforcement in the reinforced concrete structural element design, the reinforcement is given in the beam. So this you will study in your upcoming semester.